Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on reciprocal trigonometric functions. In the last lesson, we reviewed the sine, cosine, and tangent functions. We also learned about cosecant, secant, and cotangent functions. These are called reciprocal functions because they are reciprocals of our original functions. In today's lesson, we will learn how to sketch the graphs of reciprocal functions. Let us begin, students. In earlier trigonometric studies, you learned how to determine the domain, range, and period of the sine, cosine, and tangent functions. You also studied their graphs. Before we learn how to sketch the graphs of our three new reciprocal functions, let us review the graphs you have previously learned. The graph of y equals cosine x looks like this. The graph of y equals sine x looks like this. The graph of y equals tangent x looks like this. In order to graph these functions, we had to determine their domains, ranges, and periods. For instance, we had to know that the domain of the sine function is all real numbers. The range of the sine function is the set of real numbers from -1 and 1, including -1 and 1. The period is 2 pi. Students, please separate into groups of 3 or 4 using your previous knowledge of trigonometric functions. Can you determine the domain, range, and period of cosecant, secant, and cotangent functions? Work in your groups to find the answers.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. How did you do? Knowing these functions are the reciprocals of sine, cosine, and tangent should have helped. Since the cosecant function is the reciprocal of the sine function, the domain must include values of sine x that do not equal 0. The domain is all real numbers, excluding integral multiples of pi. The range is all real numbers from negative infinity up to -1, union, 1 up to positive infinity, and the period is 2 pi. Since the secant function is the reciprocal of the cosine function, the domain must include values of cosine x that do not equal 0. For the secant function, the domain is the set of real numbers, excluding the odd integral multiple of pi over 2. The range, again, is all real numbers from negative infinity up to -1, union, 1 up to positive infinity. The period is 2 pi. Since the cotangent function is the reciprocal of the tangent function, the domain must include values of tangent x that do not equal 0. For the cotangent function, the domain is all real numbers, excluding integral multiples of pi. The range is all real numbers, and the period is pi. Were these your answers, students? Great work. Let us look at how to sketch the graph of each function. Let us say we want to draw the graph of y equals cosecant x for negative pi pi. First, we must find the coordinates for our graph. We can draw a table that will show the relationship between sine x and cosecant x. For each value of sine that is 0, the inverse function is undefined. This means that the graph of y equals cosecant x has vertical asymptotes at x equals negative pi, x equals 0, x equals pi, and so on. Since we know that the cosecant function is the reciprocal of the sine function, we can take the reciprocals of the non-zero ordinates on the graph of the sine function to obtain the graph of y equals cosecant x. The graph of the cosecant function has vertical asymptotes at the points where the graph of the sine function crosses the x-axis. It should come as no surprise, students, that the graph of a reciprocal function appears to be a reciprocal graph of the original function. We can use the same techniques to draw the graph of the secant and cotangent functions. To draw the graph of y equals secant x, we use the reciprocals of the non-zero ordinates of the cosine function. Notice that the graph of y equals secant x has vertical asymptotes at the points where the graph of the cosine function crosses the x-axis. To draw the graph of y equals cotangent x, we use the reciprocals of the graph of the tangent function. Let us practice more reciprocal functions. Students, please copy down this table. Based on your knowledge of trigonometric functions, fill in each of the values. Then determine each of the following values. The cosecant of negative pi over 6. The cotangent of 7 pi over 6. And the secant of 5 pi over 2. Please work together in your original groups to answer the questions.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Please compare your answers with these. You should recall the values for sine, cosine, and tangent. When we fill in the values for this table, we simply use the reciprocals. The cosecant of 0 is undefined. Of pi over 6 is 2. Of pi over 4 is the square root of 2. Of pi over 2 is 1. Of pi is undefined. Of 3 pi over 2 is -1. And of 2 pi is undefined. The secant of 0 is 1. Of pi over 6 is 2 over the square root of 3. Of pi over 4 is the square root of 2. Of pi over 2 is undefined. Of pi is -1. Of 3 pi over 2 is undefined. And of 2 pi is 1. The cotangent of 0 is undefined. Of pi over 6 is the square root of 3. Of pi over 4 is 1. Of pi over 2 is 0. Of pi is undefined. Of 3 pi over 2 is 0. And of 2 pi is undefined. We can use this table to answer the second part of the activity. The cosecant of -pi over 6 is equal to 1 over the sine of -pi over 6. Since the sine of pi over 6 equals 1/2, the cosecant equals -2. The cotangent of 7 pi over 6 is equal to 1 over the tangent of 7 pi over 6. The tangent of pi over 6 is 1 over the square root of 3. Therefore, since this is a reciprocal function, the cotangent of 7 pi over 6 equals the square root of 3. The secant of 5 pi over 2 is equal to 1 over the cosine of 5 pi over 2. This is equal to 1 over the cosine of 2 pi plus pi over 2, or just the cosine of pi over 2. Since the cosine of pi over 2 is 0, the secant of 5 pi over 2 must be undefined. If you would like more practice, there are many additional questions in your textbook. Today, we have learned how to sketch the graphs of a cosecant, secant, and cotangent, and we have studied the properties of each function. In our next lesson, we will learn about inverses of trigonometric functions. Until next time, thank you, teacher. Thank you, students.